Hi there, and welcome to the 2026 version of Jason Makes a Winky Blink. There's another 2025 version of this on my YouTube channel as well. It's pretty similar. Talks about things in a slightly different way. So if you're thrilled by this video and you want to see that, you can go look at that. Anyway, today we're going to make a Winky Blink circuit. It's a pretty standard high school electronics project. And if you're doing this in class with me this year, I've got a handout for you. If you're playing the home version of this game and you're just watching this online, I'll just quickly scroll through the document so you can copy a few things down. Now, key things that you need to know are included in this handout. We are going to create a project file which has a schematic file and a printed circuit board file inside of that. And the schematic, as we know, is a logical representation of the board. It tells the story so a human can read what's going on. It should be neat and organized in such a way as to say what's going on in the circuit in an easy to read fashion. That means that the components can be arranged in such a way so that the circuit's easy to read. They don't have to be close to each other. You don't care how big they are. It's not a physical thing. The nets, the lines that link the components together, can cross each other without joining. They're just logical instructions on how things come together. Now we're going to change that over, and then once we've got the schematic designed, we're going to use that to make a printed circuit board design. And that is a physical representation. And you do have to know how to position the components. They have to be in the right place. They have to fit on the board. And all of the holes that you drill for them and the pads that you etch for them have to be exactly the right size. So to do that, we're going to add components to the board from libraries in Fusion. And the components are going to be linking a schematic symbol to a physical footprint. So both the symbol and the footprint are important when you select a component. And in fact, a large part of your design challenge is coming up with the right components to use in your design. Okay, so the symbol will be how we look at it in the schematic, and the footprint is what's going to be used in the printed circuit board design. Most of the components that we're using are through-hole components. You drill the hole, you slide the lead through the hole, and you solder it on the back of the board. That means our copper is going to be on the back of the board, and in Fusion, that means that the bottom copper layer of the board that we want is going to be in blue. If you see a red copper layer, or in fact any red showing up in your drawing, that's probably a problem. Excuse me, at least until we get on to the more complex boards. Um, if you're doing industry stuff, then you're probably going to be using surface mount components. Industry uses surface mount technology or SMT parts quite a bit, and you'll identify them because they'll have red on them. But just remember, if you see red, there's a problem. Now, the parts are stored in libraries, and anyone can create and share a library, which is great. Later in the course, we'll create parts for our own library, and we'll store them in our own library. Uh, but as a result, that means that there's actually tens of thousands of electronic components that you might need to use, and they're stored in hundreds of different libraries, and sorting through the libraries can be a hassle. So finding the components for your first design, making the Winky Blink, I've got this little chart right here with the names of the parts that we're going to use to make it a little bit easier for us to get started. I've got them listed, how you can search for them, what the component name is going to be when you find it, and what library it's going to be in. So when we get into Fusion, I'm going to show you how to set up some of those libraries so that they can work for you. There's also going to be different footprints for each of the components. So you can come in here and I'll show you again when we go through there. You might find a capacitor called CPOL-US. That's the American symbol for the schematic of a capacitor. And then you have to choose the right size of capacitor because depending on what capacitor you're using and what the value is, it could be different sizes. So if you don't have the handout in front of you, maybe capture a little screenshot of that screen because we're going to be referring to it later on. Okay, now here's the sample that we're going, sorry, the schematic that we're going to be building. And on the schematic, we've got all the components in the right place. The green lines here that join them together are the nets. As you put it together, you'll see that each net has a name. When we start doing more advanced stuff, we'll change the names on the nets. We'll do some fancy things with the nets. But today, they're just instructions on saying how everything's going to be hooked together. And this is telling me that this net in this green line right here connects the battery to R2 and to R1. Nets can cross each other, and you can see right down in this part right here, the nets cross each other, and they are not joined at that crossing point because there is no dot. If two lines intersect and need to be joined, we'll put a dot right in there. That will come in automatically when you tell it that it's joined, and that's how you tell that they're joined together right there. Okay. You'll notice in the final version of the schematic that there's a title block in there. There's fancy ways to do title blocks too, but you need to have your name, date, and a title for it attached to the drawing so people know what you're drawing and who drew it. And you'll also see that we've taken the names and values for each of our components and arranged them in a nice, easy to read type of view so that somebody can look at it all together. There's one or two things on this schematic that I'm not really happy with. I was going to go back and edit them, and then I thought, well, I'll let you guys look at it and see if you can see what I'm not happy about. Let's carry on. After we design the schematic, we're going to come and make a printed circuit board file, okay? And the printed circuit board file is something that we're going to use to produce our final version. You can either make it using the toner transfer technique in our lab for a single-sided board, or you can send it off to be manufactured if you're doing double-sided or more complex boards, or if you just want a lot of boards. If you're doing a class set of boards, for instance, then you can send that off and have them made at a fab shop. And by the time you've paid for all of the parts and supplies that you need for your students to make them, it's probably cheaper to get them produced at the fab shop and shipped to you. Uh, yeah, sad to say, but it saves you some money, saves you a lot of time with your class, and ensures some quality too. So if you're teaching people specifically how to design circuits and how to make a board, then definitely use the toner transfer technique because your turnaround time is a couple of hours to get a board. But if you're doing a project for the entire class and you just want them to be successful with their electronics project, maybe send it off and get 100 boards made. If they're a bigger board, talk to another teacher, see if they need some for their shop. And the more boards you buy, the cheaper they are. When we get to designing our board, because we're going to be making the shop, we're going to enter some design rules and some design preferences here that we'll talk a little bit more when we get around to taking a look at that section of the project. Okay, finally, you'll put your parts onto the printed circuit board and you will join them all together. Now here are the nets. The nets show up as yellow air wires. People find them really annoying until they understand what they're doing, and then they find that they kind of make sense. So anyway, you'll see yellow air wires that will probably annoy you and confuse you at the beginning, but they'll make sense when you get going to it. Um, Finally, we'll rope that all together and we'll take a look at how you set this out to print your board. So I'm going to slide this off to my screen. Hopefully you've seen everything that's in the handout right here. And I'm just going to carry on. And here we are in Fusion. Okay, so we're in Fusion now. And if you've just opened Fusion, it's going to come up and it's going to look something like this. And normally when we're doing mechanical stuff, we do a part design or an assembly design or a hybrid design. We are going to, not surprisingly, be creating an electronics design. So just click on that and create new. Now, if you're already in Fusion, that's fine. You could just come over to the side right here and go File, New, and it'll offer you the chance to create a new electronics design. Oh, where did I just go here? Come back to my project right here. Okay, so it's in here and it says New Electronics Design. start with a schematic. That's a really good hint. You're going to start with a schematic. So click on that blue button and there we go. Okay, now there's a whole bunch of stuff going on the screen. One of the things I want to do was I don't have my data panel showing. That's this grid of 9 squares up in the top. If your data panel is already showing, that's great. Um, so you've got a link that I've sent you to the BCIT Technology Teacher Education Hub. So you can come in there and you've joined that hub, and in the Student Projects Hub, you'll find your folder. Go into your folder and then maybe create a folder inside there that says TTED 4035 circuit boards. And if you put your electronics files in there, you'll know that I'm saving things right into there. So as you can see, I've already been through and done this project. I've got all these files in here. I'm going to create this one from scratch. And I'm just going to go right now, I'm going to go save. And it's going to say, where do you want me to save it? Well, this is in my folder, TTD 4035 circuit boards. And for me, I'm going to call this 2026 Winky Do. I just like making Winkies so much. And there we go. This has popped up here. And as we were saying, there's going to be 3 files that you need to look for. So when you see this one here, this is your project file. That is what keeps the schematic file and the PCB file linked together. Later on, you can actually use it to create a 3D model of your circuit board. And if you have 3D models of your components, then they're going to show up in 3D as well. And you can import that 3D model into your manufacturing environment, and then you can start building a case for it. It's also pretty cool if you have a case that you need to fit a circuit board into, you can build your case and get it all designed to your design specs, and then you can work it the other way around so that your circuit board outline is imported and adjustable whenever you change your case. But I'm getting ahead of myself. We've got your file saved in here. It's got a name. It shows up at the top. And when you put your mouse over top of the tab, you see it says project, and it says project right on there. And this has the schematic symbol right on here. We are going to start by creating a schematic. Now, as I said, to create the schematic, you've got parts that are stored in libraries. And so this side of your window off to the side right here, you've got a whole bunch of things going on in the tabs right here. Now the place components is the one we're looking for. You can get to that by coming in here, and there is place components. That's your command. A is the command for add, because you're adding a component to the drawing, but it should come up and should look something like this. Other tabs that you have access to over here are the inspector for taking a look at individual parts, the design manager for checking for errors. You can control your layers and your selection filter. Hopefully everything's blue in your selection filter. All right, come back here to the place components because we're going to put our components into here. So you're in the place components tab, and now you've got all libraries turned on. Now, your selection of libraries might be different from mine. Let's come in here and let's go and open your library manager. So that's this little mark right on the corner. And this helps you manage all the libraries that you're going to need. Now, looking at the handout that I gave you, you'll see that there's a list of libraries that you really want to use. And libraries are in various different categories. There's the libraries that I have stored directly on my hub, but come and click on public libraries. These are libraries that Fusion shares with everybody all around the world. And we want to find the Tinkercad library. Okay, so you can just come into here and type in Tinkercad, and it's going to search, and make sure you have the active clicked so that that's blue. Okay, sometimes libraries will update. You can see this one hasn't been updated to the latest version. I'm not worried about that right now. Um, but people will expand and improve the libraries, so there'll be more parts in them. Okay, so we've got Tinkercad turned on. We also want to make sure that the transistor-NEU dash TO92 is turned on. TO92 is the part name for our standard small signal transistor. So the 3904s that you know and love from our various projects, they're packaged inside a TO92 package. Um, and the name of that package is a TO220 package for bigger transistors and things like that. You can get a whole bunch of devices that come in a TO92 package. Transistors just happen to be one thing that might be in that package. Make sure transistor new TO92 is turned on. And then finally, we're going to look for the Adafruit library. Adafruit, uh, a commercial circuit board manufacturing company, electronics project and education company founded by Limor Fried, who likes to go by the name of Lady Ada, and her company is called Adafruit, and they produce a very nice library of parts. So make sure that is turned on and active. Those are the three main libraries that we're going to be using today. So they are turned on, and later on you'll find that coming through the public libraries is a good way to come in and search, and this is where you can find some of the parts that you're going to need. I'll also show you how to design your own parts because sometimes it's actually easier to make your own part than to find it in a library. Okay, we have our libraries that we need turned on. So now, when we've got this turned on, you may have to come in here and adjust this line on your screen right here. This is going to give you a little bit more space to get in here and see what's going on. And then you can drag that down a little bit. Um, okay, Fusion is got this tech preview thing it really wants me to take a look at, and I really want it to go away. Um, so give yourself a little bit of space in here because we'd like to see all of these parts. Um, works great if you've got a higher resolution screen. I'm working on a little lower resolution screen right now, so I'm going to have to pull that down a little bit. And how do I get, this is something new. Tech preview, how do I make tech preview go away? Okay, here we go. We're back, and yes, we're recording again. So all I had to do to make that go away, weirdly, it was some kind of glitch on my system. I just dragged this bar back and forth, and that made it go away. So if that's getting in your way and you can't see your components right up here, then don't worry about it too much. Okay, so now we're going to place some components right on here. And under the filter right here, this is where we're going to enter our search term. So you had some search terms up here, and we're going to start off with battery 9V. So now you're going to come in here and battery dash, and you can see there's a whole bunch of batteries as you search. There's battery 9V, and you can see the footprint for it is generic. Okay, so we're just going to take that and we're going to drag it out onto our board. So I clicked on that part and then I dragged it and it came out here and it says add, and I'm going to flip it around about like so, so that it is facing with the wide side up. Then I'm just going to say done. We only need one battery. Now, because I'm working on a smaller screen right now, I am just going to turn my data panel off by clicking on those three dots right there. And that should let me scroll back and forth right on there. I can move this window around by holding my center mouse button, and I can zoom in and out with the center mouse button. So pretty standard stuff for CAD. That center mouse button is pretty useful. Now, as I add these parts, I may as well try to keep them neat and tidy. You can see the part name U1 right here. I'm just going to put that right there. And the name right here is a bit long, battery 9-volt generic. I can take this part, put my mouse over top of the battery, and I can right click on it, say properties, and oh, It's not going to let me change it right there. I have to come in here and go value, and we're going to change it, and we're just going to change that to 9 volts. Okay, then I can grab on there, hit escape to get out of a command. Escape comes in handy quite often, and there we go. Part 1, battery, 9 volts. Put it somewhere in your drawing right there. Make sure that this is up because that's going to be your positive. Okay, remember on a battery, the wide side is always going to be your positive side. All right, the next part that we're going to put in is you're going to come in here and you're going to type in and you're going to search for 2N3904. And these are your transistors. Okay, now there's a couple of different transistors that you can choose from. Okay, I'm going to click on this one first. I'm not going to include this one, but it's not a bad choice. I'm just going to adjust this menu here so you can see this a little bit better. When I click on a part, okay, its schematic symbol shows up, its footprint shows up, and in this case, a 3D model of it shows up as well. Now, you're not wrong to use this part. This part will work perfectly fine, okay? Where I look at this part is I look at these 3 pads right here and I say, is it going to be easy for my grade 8, grade 9, grade 10 student to drill that hole and have enough copper left after they're done drilling that hole to be able to solder to it neatly? And are they too close together for them to solder it together nicely? We want to have a little bit of a gap. We want something that's going to be easy to solder. Now, if you're designing your own part, no problem. You can space things a little bit further apart. We'll talk more about how to modify the parts later on. If you take a look at another component right in here, let's see, that one's got the same body, but if I take a look right here, you can see this one, it's the same shape, but they've moved the outer pads right out to the outer edge here, and they've used a longer copper pad right in here, so there's maybe a bit more space between them to reduce soldering errors, and I just think this one's going to work a little bit better if you've got students doing some first-time soldering. Your schematic symbol's the same, but the footprint's different, and it will work with your transistors. So that's where I like this one a little bit better than the other ones, but the other ones aren't wrong. Okay, they're 3904s, they work great. So go ahead and drag that. It's going to come in here and you're going to need 2 of them. Now we're going to adjust their location later on, but you know from looking at the schematic, you've seen it before, they're going to be down here somewhere. Now this one's not going to be the right way around. You can hit the mirror button, and now it's going to be the right way around for the way we like to design our circuits. Okay, do not use the mirror button when you're working in printed circuit board mode. This mirror is only for schematic because here it's an idea. In printed circuit board mode, when you mirror something, it actually flips it from the bottom layer, or sorry, from the top layer to the bottom layer, or vice versa, and that creates a problem. So only mirror when you're working in schematic mode. You can say that we're done right there. You're also going to need a resistor, so we can search for resistor. Okay, and now when the resistor search comes up here, you're going to see a whole bunch of options come up. And some of them, yeah, that, that doesn't look like our resistor. Okay, um, what we're looking for is we're looking for the one with the name RUS. Okay, now when you choose RUS, you'll see that there's a drop-down menu on this side. And this little drop-down menu right here lets you choose from different footprints for this particular resistor. And why would you want different footprints? Well, sometimes you want a resistor that's a little more compact. So 0204/7 means that your resistor, when you go over to do your footprint, is going to have a 7 millimeter length from hole to hole. I like to give it just a little bit more length. I think that works a bit better for students. So that's 0207. Its footprint is just a little bit bigger, gives you a bit more space. If you really want it a bit longer, you could go to 12 or 15 as well. That's just going to make your board bigger without any benefit. If we were trying to pack things in really compact, we could go to the 7 distance. In fact, there is a tricky little technique right here. You could go down to the 2 vertical, and what you end up doing is you end up mounting the resistor vertical and then bending the test lead over and putting it in that little hole right there. We're not going to do that, and you're just going to be unhappy if you go with 5. So 0207/10 is a nice footprint to use. In the event you decide that you don't want that footprint, you can change it later on, okay, because it's associated with the component. But go ahead and click that, click right there. You've got the 0207 variant of R-US from Adafruit, and go ahead and drag that on. You're going to need 4 of them. 1, 2, 3, 4. Okay, and what else are we going to add in here? Well, I guess the next thing up is the capacitor. Now, capacitors give you a whole bunch of things to choose from because sometimes you get just the flat symbol. Now, this is a non-polarized capacitor, but as you know from having built your Winky Blinks, we're using the aluminum electrolytic capacitors, the round, the cylindrical ones, and they are polarized. So if we don't have a polarized symbol with a plus on it, or with that one curved side to represent the negative side, things aren't going to work out that well for us. Now, in here, you can see we do have variants of capacitors, but none of them are really cylindrical. Okay, so I don't like these footprints because they don't represent the ones that we have in the shop. If you happen to see these red pads showing up in here, watch out for the red. You'll notice that there's no holes with the red ones. That's because those are the dreaded fancy surface mount components that we've talked about in the past. Surface mount's actually pretty easy to work with when you know what you're doing, but it's something new and we'll do it later on. Okay, so we're not going to use the C we're not going to use the C-US. We're going to come down and in the C-pole US library, you're going to find a capacitor here. It's got the correct symbol. It's got the positive marked on the schematic. It's got the curve marked on here. And then we're going to choose the footprint that works for us. We're going to skip over the surface mount components in there. That's not what we want. We're going to keep coming down here. And as you can see, there's lots of ways to have a capacitor. There's lots of different parts, lots of different sizes. There's surface mount, there's through hole. And now you can see we're getting into some. And the numbers represent the dimensions. You can mount a cylindrical one as an axial capacitor, okay, if it comes all the way through. Here's the capacitors more that we're looking at a little bit further down. And I think the variant E2.5, okay, dash 7 is probably best for what we're doing. You can take a look at some of the other ones. 3.5-8 would also work. You're going to be off by a millimeter in your dimensions maybe, but 2.5-7 should be pretty good. So if we click that, then we can come in here and you're going to need 2 capacitors. And I'm using the right mouse button to rotate it, but you can also come up here and click on the rotates right along there. So I'm going to put one in this way, and then right mouse button rotates it twice like that. I'm going to put it in like that. There we go. I've got capacitors in there. Okay, next thing I'm going to look for is a diode. That's the final part. And so you come down here and now you can search through all the different diodes. And actually, that's not a bad diode, but the symbol right there, that's for a Schottky diode, which is a little fancier than what we're going to be using. Yeah, all sorts of fancy diodes that we haven't talked about yet. So if we come down and keep looking in libraries, let's get out of the diode library, which is where you'd think you'd find something. It's just way too specific. Tinkercad has Zener diodes. Where's the Adafruit library? What do you bet the Adafruit library is? Up at the very top, and I missed it right at the beginning. If I click sort, there we go. So what I did was I clicked on there to just do an alphabetical sort, and there's the 1N 4004. I could have also searched for 1N 4004, and it doesn't have any variance. It's just that size, and that's the right size for what we need. And that one can go in here somewhere. Okay, brilliant. Now, while we're at it, and we've got our components in here in the rough spot where they're going to be, let's just come in here and make sure that we add some values to these. So if I come to R1 and I right click on it and I go value, okay, these ones, depending on how bright you want your LED, are going to be about 470 ohms. Now, I don't like looking up ohms on the keyboard, so I just say 470R. Everybody knows that 470R is 470 ohms. And after I do that, I'll come over here and click on this one because this one's also going to be 470 ohms. And down here, this one's going to be 56K. Depends on how fast you want it to blink. Remember, 56K means 56,000 ohms. So R means units of ohms and K means thousands of ohms. And value 56K. There we go. We've got our numbers in here. Now, if you hit escape, okay, if you try to do anything right now, it's not going to help you. Just hit escape to get out of there. And now we can move this around, and I'm using my right button to rotate this. And you can rotate these around and put them into nice, easy to read format. And I know based on previous experience that putting them outside a little bit is going to work pretty good for us. You'll notice that they keep a little line so that you always know which component R4 is linked to. Oh, there's little things going on here, like why don't I move that up one and move that one up so those are nice and level. Again, neat and tidy makes for a nicer presentation on there. If you need to move a whole bunch of components, you can draw a box around them, pick them all up, and then you can drag them down. You can drag your battery up here to kind of match up with them. You know, kind of depends where you want the battery to be and how you want them to sit. Okay, so there's some components right in there. For our capacitors, let's come in here and add a value to the capacitor. So I right-clicked on the capacitor value. A very standard value is 10 microfarads, which we represent as 10U. You can use a capital U if you prefer. Small u is probably stylistically more correct. And I got that bing because I'm still in value mode, so I'll click on this capacitor and give it 10U. Okay, and then I'll hit escape. And I can get these around. I might move them around later on. I'm just doing this so you don't get excited later on and forget to put all your values in. Okay, our transistors down right here, we can move that T2 right next closer to the transistor and T1 closer to the transistor there. And if you want, you can add a value to these as well and go value. And this is a 2N3904. And this is a value of 2N3904. And then you can tidy that up. Now right now, okay, hit escape so I don't get anything too caught up. If I want to move that out so I've got a bit more space, I can slide it down. And I can slide that around so it's easier to read. Put these in the right order so that the part number comes before the part name or the part value. Okay, there we go. We'll tidy some of this up a little bit later on. And our diode, it just needs us to set this up and put it somewhere so it's easy for people to read. Okay, there we've got some labeled components. Now we're going to start joining them together with nets. Okay, now this symbol right up here at the top is the net, and this is how we join things together. Of course, it does put that window right over top of what I want to do. There's options down here depending on how you like your corners and your chamfered and how you like things to come together. The default mode works really well. Click on this end right here, and you don't have to hold. You just click on it and drag it around, and you can see it's trying to figure out where to go. And you'll see that when you connect to something that you're allowed to connect to, you'll get that little round dot showing up. And click there you go. We're still in net mode, so I can start. You can see the little dot show in, and I can come over here. And because it's joined those two there, I get a dot. When I come down right in here, this is funny. For a Winky Blink, I forgot to add the LEDs. Okay, so we'll get to them in just a moment. Let's see, we can come down here and we can put this net right in there, and our net's going to come down, and if I hit click right here, it'll let me come back up. So I click here, and now I can come over, and now my emitters both flow out to my diode. Well, I guess I better add some LEDs. How did I miss that when I was going through all my parts? I'm going to click done on adding nets. You just come back over here. You've probably done this already because you were following the written instructions. And there is an LED. It's in the Adafruit library. Okay, you might have to scroll up and down to find it. I've sorted by alphabet name by clicking on it right here. And there's lots of variants. There, you can put a 3mm LED in if you want. We've got 3mm LEDs, but I chose the 5mm LED variant because that's the one that we commonly use. Drag that in to your board and put it right about there. And right about there. Okay, again, hit escape and adjust the names so that they're going to be easy for somebody to read. Alrighty, now we can add some more nets. So we've got the LEDs added, come in here, and that one just joins up right there so that the power comes through that first low value resistor, and then it comes over to here. Okay, now I like to have my transistors aligned with the LEDs. So I'm just going to take this transistor, slide it over this way a little bit so that that's a vertical alignment there. And that's a vertical alignment right there. Okay, and now when you have the LED, that comes down to the collector of the transistor, and the positive of the capacitor comes to the collector of the transistor as well. Here, this is going to come down right there. That's going to come right there. This resistor is going to come down to the base. And again, I just click it once and I come down and I drag right there. And this transistor is going to come down. Sorry, resistor is going to come down to the base right there. And this one's going to connect somewhere in there. It's going to connect somewhere in there. And there's your schematic for the Winky Blink. Now you'll notice as we were doing that, so I'm just going to click done right here. Some of these got into the wrong space. We don't want them to overlap with those leads. We want them to be nice and easy to read. That one's not too bad, but I could take that 2N3904, put it down right there. Put that down right there. So we've got nice, easy to read part names and values right next to each of our components all the way around the board. Now we've got a couple of different ways that we can put title blocks in here, but the quickest and easiest to give ourselves a title block just before we save this is to come over to the Document tab up at the very top. If you come to the Document tab, you were in the Design tab, now come over to Document and click on the A button, and you can enter some text. And okay, let's start by calling it the Winky Blink. That's probably more important. And then after you've typed that, make it a little bit bigger. Now that was 0.7 inches, make it 0.2 inches. That's probably overkill. So pick a reasonable font size. And now people will know what they're looking at when they see that file. Great. Come up here and hit save, and you're done. Now, if you've done this all right, go ahead, grab a coffee, whatever, because when you come back, we are going to make the PCB file. Making the PCB file, let's come back to our project file, and you'll see now that in our project file, we've got the Winky file saved right here. Up at the top of the board, we've got create new PCB. Now, because this is going to create the PCB within your project file, it is going to extract all the information it needs. All of the parts that you've used, all of the nets that you've created are going to come directly from your schematic. So there, I've created a new PCB. You'll see a new file is showing up right on here. Okay, and all your parts are sitting off to the side right here. You can grab all of the parts and just pick them up and drag them into the middle of your board. Okay, now we can start placing them and moving them around in the board. And there's all sorts of ways that you can solve the routing puzzle for this. And you can do fancy and neat things. How you solve this is going to kind of be up to you. I'm going to show you a straightforward and simple way. You don't have to follow that, around. I basically follow the schematic a little bit. So what I'm doing on here is I'm just clicking on the part and I'm using my right click button to rotate it and put it into position. And you can see those air wires, the yellow wires are showing me the nets and how things are connected. Now the nets right now are just drawing the closest line. But if I look at this net right here, you can see it comes off this side of the diode to the two emitters. When you look at the front of the transistor, it's always a good idea to look at the front, and our 3904s are emitter base collector. So the emitters, yep, they are going to the diode. There are times when people have mistakes in their parts, so it's good to be alert for that. Okay, and then you're going to move your capacitors around. They can fit somewhere in the middle right here. Now, how you orient them is going to make your routing job either easier or slightly more miserable. Um, so you can place them in however you want, but just remember you're going to have to route it later on. And then that LED we're going to put over here for now. Probably easier to turn that capacitor around. Did you see why I thought it would be easier to turn that capacitor around? Because that's a direct line right there between the positive side and the bottom of that LED. Now there should be a link from Ah, that one, you can see the air wire comes over to here. And if you refer back to your schematic, LED1 and C2, let's just pop over here. Okay, LED1 and C2, they're connected to T1. So that net that we're looking at is right in here. And maybe it's going to be easier if I put T2 on this side and T1 on that side. We'll see how all that comes out in a minute. So this is where the trick of designing a board comes from, is getting the parts where you want them to be, getting them all nicely spaced so that you have enough room to route everything, but that you're not wasting space and you've got a nice compact little board that is kind of pretty. Now careful, there I clicked on the number. Okay, I didn't want the number to move, only the numbered highlight at that point. If I click on the whole component, I can lift it up right there. And I'm going to bring it up over here. Now, right now, it's okay that that's overlapped with something else. There we go. I can pick up that part and put it together right in there. I can pick, now again, there I've only got the 56K. Okay, I can just hit Control Z. That'll undo what I did for putting that there. I can pick this up, right click, move that down, and there you go. There's some interesting crossovers in here. You see how those LEDs are crossed up? I wonder if my life would be easier if I took this, moved it over here, moved that over there, move that over there, move that over there. Oh, now I've got some crossing down here. Well, I'm going to get some crossing one way or the other, but playing around with this to reduce the amount of crossing in your air wires. Oh, that reduced some crossing right there. Well, I've still got some air wires crossed, but it might not be too bad to route. We're going to have to see as we get going forward right on here. So give yourself an arrangement. Might look something like this. It might be a little bit different. You might decide to do something entirely different and you know, go for your own unique creative design. That's perfectly okay too. If I wanted to make this board a little more compact, I could bring these ones right down in here. And now my board is a little bit shorter. That just saves a little bit of space. Maybe lets me tuck my battery in right over here. All sorts of things you can do to make the board a little bit more different, a little bit more compact. Anyway, something that you are going to have to do before you start routing your board, and I've given you in the handouts, okay, page 3, we're going to have to change some of the design preferences. So for the design preferences in here, we're in design right now. Let's come into the rules. And the first thing we'll do is we'll come into design rules, and we're going to change the design rules so that our wire to pad clearance, the spacing between the traces or tracks that we make, okay, is 20 mil or 20 thousandths of an inch. I'm not going to worry about the vias. Vias are for double-sided boards. If I was making a double-sided board, I'd be worried about that, but I'm not. I'm going to worry about pad to pad clearance. You can see over on this side, it's giving you a diagram of what you're working at right there. This is the minimum distance in between pads. Again, I'm going to set it to about 20 thousandths of an inch. These numbers can vary. This is why numbers that I find work reasonably well for making your own printed circuit board with toner transfer. You can make these, if you make them a little bit bigger, then you've just got more space. Pad via, I'm not worried about vias. SMDs, I'm not worried about. Those are our surface mount devices. Board outline clearance is already set to 40, which is pretty high. We're not using a restrict mask or vias. We don't have to worry about that. We do have to worry about the copper width. This is the minimum width for your copper wires, and I'm going to double click on that and set it to 20. Pardon me. Now I can click OK. I've changed the, there was one other one right here, wire, wire, wire. Ah, I missed wire, wire right up at the top. I scrolled down too much. So wire, wire is set to 20. Wire pad is set to 20. Pad to pad is set to 20. And copper width is set to 20. Those aren't magic numbers. They kind of work, but if you set them up to 25, that would just give you a little bit more clearance. And if you set them down to 18 or 15, you could probably still make the board just fine. Click OK right there. Then under preferences, we're going to come into design preferences. And this is a kind of cool one. We're going to come to the annular ring. Now, when you drill the holes, the annular ring is how much copper is left around the outside. And that's usually controlled by the part definition. But I'm just going to tweak this a little bit and show you the difference that it makes. I'm going to move it off to the side here so we can see a bit more easily. I'm not worried about the top. We're not making a top copper layer. I'm only worried about the bottom layer. And I'm going to set this up to 20 mil. And just watch the outline around those little green pads. Where am I going to be able to put that? Okay. This is a lot easier to do on a wider screen. There we go. And I'm just going to click OK and watch what happens. Did you see them get just a little bit fatter on there? That just means that you're going to have that little bit more copper left if your students make a mistake. Now, you could keep setting that up higher and higher still. Okay, so under preferences, I could try 25, design preferences, annular ring. Just remember that you have to have your maximum size go up if you're changing your minimum size. You can't have a minimum of 25 and a maximum of 20. And there you can see that you're starting to run into problems. You see that little blue error? That is indicating an error because these two are now getting too close together. We'd set our pad to pad clearance, and now when we go up to 25, we're getting an error there. So Control Z will undo that and take us back to the 20, which was perfectly fine for our pad clearances. Okay, now that we've got that all set up, we're ready to start routing. Come back to the design tab right here and put yourself, this is your layer that you're going to be working on, and choose the CB, the copper bottom layer. So this is blue now. Remember we said we don't want to see any red on here. This is a single-sided board. We're going to be putting copper on here. Now think of your screen as your printed circuit board, and you can see through the screen. So these components right here are on the top of the screen. They're on a layer that's on your side. They're sitting up on top of the board. The holes go right through the board, and the copper that we're drawing is going to be on the back of the board, on the back of the screen or on the back of your board. So you can come in here and under Route Manual, you can come in here and start joining things together, and you get that happy little bling sound when things join together right there. Depending on the sequence that you draw them out, you get some nice joints. Again, you can click on how you want your traces to bend. I generally go with this second one right here. Works pretty good for me. And this one says it wants to come over. Now, if you want to put a bend in the middle of the line, I can click right here, and now it follows that around over to there. These ones come along, and I might come out a little bit right up here. Join that together right there. And make sure you get the center button and you get that bling sound. You don't want any little stub ends left sitting around. Now, this one right here, well, it's pretty easy to make that join, but now I'm left with that air wire there, and this air wire right here is a little bit of an awkward join. Now, the air wire shows this joining to right here, but really we already have the net coming up right here on that copper trace. So anywhere along that net is exactly the same place to join. So I can come up over this way and join that right there. And now that air wire said I had to have these two connected. Well, that's now connected by coming around that way. This gives you a hint on the final one right here. It's going to come up. And it goes on quite the run. And it comes right in there. Now this is a little ugly right here. I'm going to hit escape and just tidy that up so it's nice and square. And now my board is reasonably well routed. If you want to know that you've got it all routed, okay, come over here and on this side, click on the little error check. This is really critical. If you set your design rules up right and you've drawn your schematic correctly, this tells you that you have no errors and everything on your board can be manufactured. Now, you can come along and you can tweak your board, you can make it more compact, you can make it a bit neater, but I'm going to show you a few things that I do want you to do before you say it's all done. I'm just bringing this in to make it a little more compact. Don't get your traces too close together. The more space that you give yourself on there, the easier it's going to be to etch everything. If you can get nice straight runs like that, that's prettier and neater. Um, right here, if I give myself a little bit more of a gap between this trace and that pad, well, that means that if the student has a problem soldering that pad, it's not going to glitch onto the trace right there. All right, what are we going to do next on here to finish this off? Well, we're going to need to mount this board. And to mount the board, we're going to put some through holes on it. And these are non-plated through holes. In other words, mounting holes. They're not connected to any component. And to get a 1/8 inch or 3 millimeter diameter hole, that's about 125 thousandths of an inch. Okay, I'm just going to click done. Then I'm going to click hole again. It knows I want 125 thou. And then I can maybe put one right there, right there, right there, and ooh, that's a bit of a tight fit right there. I do like symmetry in my designs. Oh, see that? We got a little error and something popped up on the errors right there. There's that blue showing an error. So I can come in here and I can move that away and the error goes away and I'll match that up. Now, something else that I've found that works really good is while we're putting the non-plated through holes in there, let's just put a couple more in right here. And if you've got space to put two little holes like that, okay, notice how it was going to come too close to that line, so Fusion just moved that over to so it didn't become an error. If you do that, then when you solder your wire for your 9-volt battery on here, you can run that wire through this hole and back up this hole, and this serves as a strain relief so that your 9-volt battery clip doesn't fall apart. Okay, it just saves you a lot of maintenance to think about how am I going to strain relieve things as you're putting them together. All right, what else can we do on here? Well, here's our board outline, and we can come in here and we can shrink this board outline. Make sure you keep it nice and square. And the board outline can come up nice and tidy like that. That helps me see that I've got a little bit of asymmetry on that bottom hole, so I'll just bring that down. So those 4 holes are all kind of symmetric to each other. And then I want to put my name and date on here. And to do that, you're going to come into Document, and you're going to draw some text. And you're going to say, Winky Blink, J. Brett, March 2026. Okay, and you're going to say, whoa, way too big right there. You can probably take your text down to about 50 mil and still have it show up really nicely. Now you'll notice that that is mirrored on your screen. Remember, this is on the copper layer that's on the back of your monitor. So if you could take your head and whip around to the back of your monitor, that would be clear and easy to read. It would be the right way around. Okay. Now let's see. Some things on here are a little bit of a mess. So this 9-volt is right over top of a hole. Bring that right over here, and the 9-volt should be right next to the part number. Okay, D1, can we flip that on its side so that it is easier to read? And oh, the value might not come out that easy to read. LED2, maybe we can put that right up here somewhere so it's not covered up by the LED. T2 can come in right here, put that right there. Now, unlike in the schematic, I don't mind if you put this, this over top of the background trace right there. The reason I don't mind that is because they're on different sides of the board and the board is opaque. So if we come over to our layer stack right here, so come over to display layers on this side and tell it your layer set that you want to see is preset bottom. That's what's on the bottom of your board. That's all the copper on the back. If you come to preset top, this is what's on the top. So this stuff is going to show up just fine on the top of the board. Okay, and if you go preset standard, then you get all the layers coming back. Oh, we lost our value layer on there just as well. We probably don't really need it, but you can go ahead and put C2, C1, turn T2 up so it's easy to read. LED1 can come right up here. Again, you can put it right over top of the copper. Just don't put it over top of another component unless you absolutely have to, because that makes it more difficult to read. Also make sure that you position it in such a way that it's easy to tell which component that's referring to. Ooh, not a lot of space to put R1 in there. Oh, it might sneak in right up there. Now, if something's not fitting in quite perfectly and you want to sneak it in just a little bit, there's a grid snap on the board and you can only adjust so far. But if you hold down Alt, that lets you get a fine adjustment and it overrides the grid snap on the board. That was holding down Alt for fine adjust. Did I get all of my settings right on there? Yeah, that's looking pretty good. Okay, so we can now hit save. And give it the name. We were calling this 2026 Winky 2, or in your case, maybe Winky 1. Okay, now that is saved in a file right here, and now we've got the schematic and the PCB saved inside the project file. When we come back to the board, we can see the board right there. We've got board outlines. Now, if we wanted to do a toner transfer, we're not going to manufacture this board in class, but I am going to get you to print a PDF version of this so that you can hand it in to me and show me that you've got it all done. And so what you're going to do is you are going to print this out. And to do that, we come to manufacturing and, oh, sorry, it's under document. Documents and print. Now, before we go to print it, okay, we can print the whole board like that. That works fine, but we want to get just the toner transfer. So come to your layer set, click on the layer tab. Under here, go to preset bottom. That gets you all your copper. Okay, this is what's actually going to print out. It gets you your holes, your board outline, the copper. And you see we've still got those little cross hatches on. They're really useful for picking things up and moving them around. But they get in the way when you go to etch, because if that part's there, it's going to short out between the two. To turn them off, you need to come to View, PCB Origins. Those things are called the part origins, and turn them both off. Turn them both on again after you've printed, but you can see they've disappeared now. And now you can go File. Oops, what am I saying? You can click on the print button. And there's your board ready to print. Make sure that you have black and solid turned on and your scale factor is 1. Okay. And to get a PDF, I find Microsoft Print to PDF works very well. Okay. You can give it an output file, save this somewhere where you're going to be able to find it again. So documents or whatever you want to save it in. And make sure it's got your name on it. J. Brett Winky 2026 board copper layer. Okay, and then click OK. And now you should have a PDF of the board copper layer. And if I take a look at my files, documents, it looks something like that. And you can zoom in on it to make sure it's all good. And nice and neat and tidy. If you'd printed that, we could have done a toner transfer off that, and you would have had your design. So once you've done that and you've got that printed out, if you want to print out the top layer, go Preset Top, and this will give you your parts guide and your component placement so that you know where to put everything. And you can come in here and you can print that one out. And again, come to print. You're already in print to file, output file documents, Winky 2. I'll just say documentation. Now, for this one, if you're going to do the toner transfer, you actually do have to mirror it. So for the top documentation, if you're going to copy that, you have to click the mirror button on, unless you're going to use it in a Word document, in which case you don't want it mirrored. So for toner transfer, you do have to mirror this layer. This is the only layer that you mirror for toner transfer. I'm just going to print this out so that I can use it as a guide in a Word document or something like that. Click OK, and that comes out. And that should be in here. It's not the right one. It's coming up to my copper layer. Just a minute. Did that not print for me? What did I hit wrong? Print, print to file. Oh, Microsoft print to PDF works better. Output file, Winky 2 documentation. And there's Winky 2 documentation. And now I've got a documentation layer that's all nice and easy. You can copy and paste that right into a Word document if you want to show students where to put all the parts. And finally, come back to your schematic. And oh, there's our schematic right there. And again, under document, you've got a print file. And this one is, you don't have to be quite so fancy. Um, choose Microsoft Print to PDF, works best for me. And I'm going to call this Winky Schematic. And black and solid usually works out fine. You can turn off the black part if you want, but then you end up with a bunch of grayscales coming out on a black and white printer. So black and solid works great. Say OK. And you should have a file that comes out looking something like that. So now you've got a nice Winky Blink schematic. When you've got those three files, call me over, let me see what you've got done, and you've completed everything you need to make your final Winky Blink assignment with me. All right, folks, make sure you hit save before you're done. Save that project file, okay? Be very careful that when you're working with these files, that you don't just go and delete one of them. Okay, if you delete one of them, then you're leaving everything unlinked. You've got to keep them tied together in order for them to work properly. Uh, there we go. It's on your folder. I'll be able to go in and take a look at it and help you out because it's all done through the Autodesk Cloud. And now you can close this off and you are done for your first circuit.